Okay, without further ado, I'll get things kicked off. So thanks everyone for joining today. Really great to have you here, especially so close to the holidays. I really appreciate you taking the time out. We really enjoyed the last Unity Dev Meetup that we did, so we decided we'd do another one. We were going to run it last week, but then that clashed with Cyberpunk being released, and we thought a lot of you and a lot of us wouldn't be about. So we decided to push it to this week. So thank you everyone for joining at this time. Really lucky to be joined today by Kieran Nee, who is a principal programmer at Mediatonic. So thank you so much for joining. I actually had the pleasure of working with Kieran about 3 years ago. So it's really cool to see you again. And then we'll have Yaroslav, who'll be doing a talk afterwards. Works as a lead programmer here at Product Madness. So really excited to have him here as well. And you'll also have a new host tonight, someone that actually knows what they're talking about when it comes to Unity. So we've got here Nick, who's another lead programmer on a different app here at Product Madness. So really happy to have you all here. And Nick will be a much better host than me. He actually knows what he's talking about when it comes to Unity. So anyone following, please do, as the talks are going, ask any questions. And at the end of each talk, we will put those to each presenter. So please do get your questions ready. You can drop them in the Q&A panel at the bottom. We'd be really happy if you could drop those questions there. And yeah, afterwards we will record this as well, so you'll be able to watch the recording on YouTube. But without further ado, I'll get out your way. I'll hand over to Nick. If you just want to say a quick hello, and then we can get started.
Hi, good evening, everyone. I'm Nick, lead programmer here at Product Madness. Just go easy on me first time hosting, but hopefully you have a good time. We've got some really interesting presentations for you.
Awesome, thanks, Nick. And you'll do better. I remember last time with the questions, I didn't really understand a lot of how they were even supposed to be kind of framed. So it's going to be much better having you with that. So without further ado, unless he's decided he's off, no, he's back. I thought you might have changed your mind, Kieran, but yeah, let's get going with you. We're really excited to be joined by you this evening as well. We'll get out your way, and if you're ready, we'll let you kick off the first talk.
Brilliant. Thanks, folks. Sorry about that. That was just a quick request of, I know you're cooking dinner, but can you turn the music off? And I will just get into... Okay, so can everyone see this? I don't know.
Yeah, we can see it. Looks good.
Brilliant. Okay, so just to kick off, Jake asked me to do a talk, and I was like, well, normally I do stuff about getting into the games industry, what you'll find there, because I've been doing this a long time. I've been doing it since 2004. This doesn't feel like that audience, and we're all Unity users. And I thought, what else do I know? I know how to make Unity do what Unity doesn't want to do. And I think you'll find, most people have found that a lot of the time, that's basically the whole job. So without further ado, I'm going to talk about fighting the engine and ignoring the way Unity wants to work. So let's get very clear. I do love Unity. I've been using it since 2011, off and on, nipping back into custom engines and UE4 occasionally. I've used it my entire career at Mediatonic, but it's not perfect. It's not ready for every single kind of game you want to make. And as an ex-colleague of mine mentioned literally 2 days ago, the best game genre to make in any engine is the one they had in mind when they make the engine you're using. So in Unity, you go back all the way to like Raptor Safari, and it's third person, 3D, and fairly lightweight, not too heavy on the graphics or anything like that. As it's evolved, Unity themselves got out of making games. So features have been added and worked on and prioritized based on usually what's the most shiny for engine users and what the customers. That doesn't always equate into what we actually need to make our games. But Unity is a fantastic place to start making a game. You don't have to write so many things. Core asset unloading and unloading, scenes, prefab, scriptable objects. You don't know how much of a pain it is until you go back to a custom engine and you have to remember how to do it. Like having to deal with stuff and loading files and then parsing them is time you have to take where you're not making the game. Unity does that for you. Platform support. New platform comes out. Nowadays, they've almost always had communication with Unity for a significant period of time before they even announce, so that Unity has support ready to go. You can't underestimate how much easier that makes your life. UI, almost all your games are going to need UI. You're going to have to do user interface at some point. Some people will complain about Ret Transform, how long it took for Unity UI to come out, but it works. It's pretty good. It's reasonably performant, and it's right there ready to use. So this is quite a long phrase, dynamic content replacement without rebuilding the game. What I mean is asset bundles, like the ability to just download data to something that's gone through CERT, that's gone through Apple CERT, that's gone through the Android approval process, without having to go through that again. Like being able to update your game without actually, you know, rebuilding it and going through the painful process where they go, no, actually, it didn't pass this one tiny little thing that we let you through on last time, but now I've got a different person. That's important, and it's a lot of work, and it's something Unity has baked right in. And you have to do a little bit of work to get it working, set it up, but still a lot of time saved compared to writing yourself. It's right there in the name, Unity 3D. It renders stuff in 3D. Yes, there's OpenGL demos out there, and there's a whole bunch of like open source things, but this is rendering in 3D on almost every platform, and with experts fixing the bugs for you most of the time. And last but not least, extensive editor tooling. So you can do so much in the Unity editor, it's ridiculous. In my current project, we make use of Odin Inspector. A few of you might have used it before, but basically it's like an extension, and it adds a whole bunch of extra attributes and drop downs and all that fun stuff. If you've not written editor tools, I'd be very, very surprised. However, all that great stuff, it can actually be really frustrating to make the game you want to make, or the game that your designers ask you to make, because they come fresh, usually from, I want to make a game, I don't care what it's made in, I want these things to happen. So before we talk about that, let's talk about what people perceive as possible in Unity. Basically, it all comes from three big sources. People think things can be done in Unity based on tutorials, what you can buy in the asset store, and successful games. So they all have strong aspects for like learning Unity. You know, they're not bad tutorials, they're not a bad thing. The asset store, it's not a bad thing. You know, you can get so far just by buying some stuff that does a lot of things for you. But they're shortcuts. Successful games, again, they're not a bad thing. I used Thomas Was Alone there because when you think about it, it's been ported to pretty much every platform that's come out since it was released. So that one game that launched Bithell Games has been continuing to feed money into Bithell Games because it's a Unity game. We've all started with like the classic making cubes move, which is like the basic Unity tutorial. It's like the first thing you do to get a feeling of, oh my God, I'm a game developer. Thing is, that's not usually anywhere near close to being a finished game or what designers want from the game. However, like you said, Unity's got a lot of tools. It's a collection of fantastic tools. Sometimes you have to fight against how it wants you to use them. So broadly, there's two categories. There's the player, which is everything built, you know, the renderer, the UI system, the lighting, shader support, plugin support, platform support, and the editor, you know, the data I talked about loading, the inspector that you can customize easily, the art importing. You know, if there's a format out there, someone's either at Unity or independently written support to import it. You can extend the user interface. You can extend the menus just by adding attributes. You can build tool chains quite easily just to do, you know, pretty much whatever you want. It's a very flexible editor. And for anybody in here, and I'm sure there is, that's used Unreal, like extending the Unreal editor is nowhere near as easy. Like I look at Unity editor coding as fun. I look at Unreal editor coding as pain. And that's nothing against Unreal. It's a great engine, but it's just not as quick to get things done. So I'm going to talk about some ways in which, you know, I've fought Unity, and I would probably say I've won. I'm going to start with the last game I was lead programmer on at Mediatonic, which is Gears Pop. Gears Pop came out last year. Well, it feels so much longer. So predictably, we got asked for certain things. It needed 3D graphics, great. Unity does that for me. Needed mostly 2D battlefields, brilliant, even simpler. Complex user interface, again, great. Unity has that built in, lots of documentation, lots of ways to work. Large amount of content, again, it's a great engine for that. Ability to update that content, asset bundles, downloadable content, all that fun stuff, totally doable. Support 3 different platforms. This was the fun. iOS, Android, and it was a Microsoft game. The Gears probably should have given it away. So we had to support UWP as well. Ironically, the last game that Microsoft will ever release supporting UWP, because right after they supported DirectX and more raw sandbox features. A bit frustrating, and no matter how much I begged, we couldn't do that. What it also needs that isn't part of Unity's core feature set is a data-driven simulation. All the characters and stuff had to be driven from the content we could download at runtime. Yes, you can do some of that with scriptable objects, but it had to be done in a nice, easily parsable way for our engineers and our designers to actually work with, basically via a web page. And it also needed 2-player multiplayer with hack cheat protection that validates game results on the cheap and without running Unity itself on servers. So basically, Unity players, they're fairly complex applications. You do a whole bunch of stuff you don't actually need to run game logic. So they take a whole bunch of CPU time that they don't need. They take memory they don't need. If you just want to test game logic and keep your bills down, and remember with servers, time literally is money, you need to have it stripped down and using as little CPU and as little memory as possible. So how do you run the game without running the game? Well, it's pretty easy. You remember the game's a set of rules for how you interact with data. And that's going to be the same for any engine you ever work with. The game is not the Unity player. The game is not mono behaviors. It's how choices made by the player affects choices made by another player, as interpreted by an arbitrary rule set, which in this case included things like physics. Doesn't have to be written in using anything in Unity. It just has to interpret data through that rule set and and spit out the results in another form of data that can be interpreted by Unity itself. So once you're doing that, the rule set can be run independently of Unity. All Unity is doing is feeding data in and interpreting the data out. Simple solution, you write it all yourself. You do it in C#. C# is easily compilable down to pure C# DLL that the server can then run hundreds of instances of the game via that DLL on your servers at a fraction of the price of full Unity supporting servers. However, when I say write it all, I mean everything. And especially for a game like Gears Pop, we had to consider the fact that it was running on 4 platforms. Azure servers, UWP on whatever Windows machine the player is playing it on, any Android machine that supports from Android 5 up, in fact, it might be an Android 4, and pretty much any iOS device that is still, updatable. So you had to worry about floating point inaccuracies. We rewrote everything. We wrote all our physics from scratch, and we did it in fixed point maths, which meant we had some fun things like the fixed point library we were using had a 64K upper bound limit. So if the battlefield got too big or the calculations got too big, you basically run over bounds and you get really screwy behavior and things go horribly wrong. Debugging's hard. Determinism is hard and easy to break. So you guaranteeing that DLL or those simulation rules are interpreted exactly the same way on all platforms, really, really easy to break, especially if you use any Unity features. You have to stomp down hard and make sure that anything will go into DLL never, ever touches any Unity libraries, namespaces, anything. Long story short, though, we shipped it. Didn't ship on time, but we shipped it before we had to. It ran on all of them. The process itself was actually so successful that Microsoft tried to patent the approach. that led to an interesting discussion about, wait a minute, we wrote this. And also lockstep determinism is a very much a known thing. Like, people have been using this as far back as some of the earliest RTSs and even further. But the way we did it, they thought was patentable. So case study number 2, this is another one of my games. So It's Tanks is, I call it a side project now, Bit by Bit Games, but it was an indie company I founded with a friend in 2011. And basically, It's Tanks was our first Unity game. As such, you didn't need too much. It was basically about learning Unity, deploying something through the App Store and seeing how it worked. Started kind of with the idea of worms, but then we got distracted by making really high fidelity, nicely carved out landscape. So running through the Unity features again, we had to support an iPhone 3G. That thing was slow. 2D image rendering, user interface, Game Center SDK support, and all the fun bits of extremely fast, high number of vertex count procedural mesh creation to generate landscapes, and then blowing those landscapes up with nice, smooth curves and obviously perfectly spherical dents. You can see at the bottom, we did get there. However, we had to write it in C++. To actually process that number of points to make up the landscape, we got, and this is genuinely the speed up we got, 1,000% speed up by just passing the points out into C++, doing all the actual calculations there, passing the data back into Unity and using that to generate our collision mesh and our actual visual mesh. No garbage, no C# garbage collection spikes, just a small tiny spike compared to the iPhone 3G locking up for several seconds. It's even easier nowadays. You can just write C++, Java, whatever class, I think Kotlin as well, and in a folder, and Unity will automatically create the DLL for you. That's considerably more straightforward than the way we did it, which was write everything in Xcode. Well, when I say we did it, my friend and business partner actually did most of it. But the important thing was realizing that Unity allows you to do plugins. And if Unity doesn't actually do what you need, you can turn to other languages, other integrations that do actually do what you need. Sometimes that's by writing yourself, sometimes it's by buying something in the asset store, sometimes it's by finding an open source integration. But the important part is, as an engine, it's not precious. Well, not particularly precious about letting, oh my God, massively sped up for you. I said, yeah, that's right. It's not precious about letting you do things in different ways outside its playground and sandbox. So case study number 3, Yahtzee with Buddies. This is another Mediatonic game that I worked on for a brief period. More accurately though, it's a Scopely game. Scopely developed it originally as 2 completely non-Unity games from scratch, parallel code bases on Android and iOS. Right up until 2016, we decided that was a hell of a problem and started porting over to Unity. So they had 1 code base, 1 set of problems. And just after that, they also, Mediatonic got involved to work on new features, expand it, take over most of the actual day-to-day dev work. That's what the game needs. When I was complaining about what Gears Pop had to run, that's nothing. Yahtzee has such a huge audience. It has to run on the lowest Android devices. It has to run well. It has to have a huge amount of complex UI. It is almost entirely a 2D game, and at that point, particularly, it really was a 2D game. You have to, again, update content outside of rebuilding the game because live ops requires fresh content. You cannot keep players interested if you're not feeding them more and more and more, but without going through CERT. They needed, and this is the best trick, they needed the ability to retheme and easily change the entire UI in game as part of a build step. So for those that have never heard of Yahtzee, that's fine. But there is another version of Yahtzee called Dice with Buddies. It's the same game. It's exactly the same game with some slightly different balancing and a retheme as part of a build step. There was in fact a third as well called Dice with Ellen, as in Ellen DeGeneres. it was very similar. Retheme, different build step, and a lot of people from the Ellen show plugged in. So Unity enabled this. It has a great post-processing and pre-import series of steps. You can just mess around with whatever you want and just change the data. At the time, it didn't have much of 3D requirement, mainly because it had to run such wide devices, but later 3D was added because Unity supports 3D. But core, this isn't something that the engine itself offers, but ongoing reliable support was an important thing. Like, as I mentioned, Yasuo Buddy started as 2 separate code bases, 2 separate successful code bases. Yassi's been consistently in the top 100 grossing mobile game for years, literally about half of the last decade. You cannot have that game break. You must be able to fix it fast. And if there's a problem in the engine, you have to be able to reach out to Unity support and get it fixed as fast as possible. So this one isn't particularly a case of what did Unity offer that supports the game's needs. It's more highlighting the fact that what the game needed wasn't actually the kind of game that most people use Unity for. In fact, I've worked on another similar heavy UI game. Unity is right there in the name, Unity 3D. It's meant for making 3D games. But if your game's UI, all the other features are there to be used. So that's me pretty much at the end. All I'm going to say is, why do all these people use Unity? It's flexible enough to make almost anything you want. Just a little bit of work, a little bit of fighting with how it wants you to start and make things. You can make the games you want, and you can make the games your designers want. And if you're really lucky, they'll be successful, but it's worth trying. Like, it offers so much to just start. And I know I sound like a Unity fanboy, but it's because I really kind of am. That's me.
Awesome, awesome. Thank you for your talk, Kieran. It was a really great insight into like the realities of working with Unity. Right, we have one question in the Q&A at the moment. If anybody else has any more questions, please put them into the Q&A. An anonymous attendee has asked, what is lockstep determinism?
Sorry, I skated over that one. Thank you very much for asking. Lockstep determinism is basically where you run the exact same simulation in multiple places with the exact same inputs, and you rely on the fact that they will have the exact same outputs. So it's a really cheap way of doing networking. So Gears Pop, for example, it runs the same simulation on the server and both clients. And all it works with for networking is literally what inputs the players make. So deploy Marcus Phoenix to here. That's the input that gets networked. And then the other client just runs the exact same simulation. And then at the end of the game, the server, well, percentage chance, the server will then validate your game and that you haven't cheated by saying, okay, this is what client 1 says was the result, this is what client 2 says the result. Do they match? Okay, if they match, great, you didn't cheat. If they don't match, you run the same set of commands through the version on the server, and then you'll find out who cheated. Because as long as you haven't messed up and broken lockstep determinism, the person whose result doesn't match the server is the cheat. And this was hugely valuable. Predictably, when we shipped an Android version and we shipped a PC version. So these games were hugely hackable. Like, we had a turnaround of 2 weeks for pretty much everything in the Android APK being cracked, and people starting to use cheats to try and speed up games and take advantage and win things. What they didn't know was on the back end, we were just going, no, sorry. We know you cheated. You don't get GAC. And we did it cheap without running the whole game, just a DLL set of commands, very, very fast. You could run an entire game in seconds versus, a 5-minute game.
Cool, thank you for that. There is also another question about lockstep determinism. Does lockstep determinism use hashing, or is it using commands to replicate the state?
it's commands to replicate the step. We did use hashes as well, just as validation steps, sort of. We send those every so often. And if those don't match, that's another clue to the server to, instead of just using the, okay, I'll validate every X games as a double check. If any of the hashes don't match from the clients, it will run the validation step. It's a guarantee, which is great because it generally means that you will catch the actual the cheats.
Awesome, thank you. Another question from Tim O. Do you feel like there's a potential in losing designer-facing code when bringing your code through DLLs?
It's actually the interesting thing. We did do that. And you're right, we did lose designer-facing code, and we lost the ability to debug in Unity. And then we undid it. And we kept all the C# simulation code in Unity, and then built out of Unity as the next build step. We literally just copy the folder out, build it into a Visual Studio solution, build that Visual Studio solution to make the DLL, and the server used the DLL. So the client always used the raw code, which was good because it meant we could also, if, for example, on Windows, we actually used a thing called Arxan, which is a hugely expensive encryption. Oh, encryption is probably not the right way to think of it. It's a executable protection mechanism that basically jumbles up your executable and then reassembles part of it at runtime. And if our C# code wasn't in the Unity client, then we can have protected any of the actual simulation code, which is pretty important. So yeah, you're absolutely right. We would have lost the designer-facing code. We just kept it in Unity instead, and DLL was purely for the server.
Awesome, thank you. There's a question from Stephen Cole. He says, you mentioned you found your C++ plugin was 1,000 times faster for your custom landscape system. I'm assuming you started building it in Unity, then switched over. Now, when you are working on new tools, etc., at what point do you decide to give up on Unity and switch over to something else?
You're 100% right. We wrote it in Unity. It was our first Unity project. We assumed naively it should have the power to do what we wanted to do. I believe the thought process went, well, Worms did something roughly equivalent way back on PC 20 years ago. It should be fine. And we got rudely awakened. Now it is very much, I'm further along in understanding Unity and its limitations. So I can usually judge quite early, but also still answer it's profile, profile, profile. Like if you've got anything you think is going to be expensive, you make stress tests. And as soon as you can, you run those stress tests and then make the decision. So far, I haven't actually had to kick things out of Unity very much because it has improved. And to be honest, I'm working on different kinds of games, but it's always in the back pocket. As I know C++, I wrote a good 10 years of it before I switched to Unity. I can switch to this. It's not that different, and I can get huge speed up.
Cool, thank you. There's one last question from Tomo. Do you think it would benefit Unity's reputation if they did not force the splash screen on every game? I'd
say only if they can time travel, because I think Unity's reputation was harmed by early games, early adopters that tried to release games that just weren't up to the quality of some of the games that are made now. I mean, if you think of games like Ori and the Blind Forest, or the sequel whose name I always forget, but they're absolutely stunning. You know, if those were the Unity games people had seen first, the perception of Unity would be very different. And there's not much they can do about that.
Awesome. Thank you very much. There's no more questions. Thank you for your presentation, Kieran. It was awesome.
It's fun. Sorry if I ran through everything a bit fast. Timing wise, I always run a bit close to the edge. Sorry.
Yeah, no, it was super cool. Thank you. Right. All right, everybody. Next, we have Yarrow with his presentation. Yarrow. hold on one second. Let's see if we can get him.
Hello, hello. Yeah.
Here we are.
Fortunately, yeah. My internet service provider is not like good to me today. So
Sure.
yeah, I hope I'm. Yeah.
Okay, cool.
But that's life.
No worries. If you're ready to go, then
Shall I?
share your screen and take it away.
Cool. Cool. Can you see it?
Yeah, we can see it.
Nice. So yeah, good evening, guys. I hope you had a nice Thursday and you're ready to listen to some interesting topic. So basically, words aside, let's go to the contents of this presentation. So basically, we'll discuss some key points while creating a framework. And sorry, these guys who thought that we will actually build the framework on this one. But from my experience, I can say it's pretty difficult to build one in 40 minutes or so. So yeah, that's going to be mostly around the whole problems that you need to solve and basically the vision that you need to have while you're planning to build your little body. Yeah, let's go to who I am. I am who I am, basically. I'm a developer, lead developer in Product Madness. I've been here for a couple of years now. Before that, I worked with different companies. You can see some of them, some logos on the screen. It was an interesting journey in my life. I worked with like different and various companies, from small startups that were going up and like pretty mature companies that were going down, and like different projects, different sides of projects. And like I'll try to share some of the knowledge that I got during this wonderful journey with you guys. Yeah, so back to the topic. So let's imagine the scenario where we have a young company or a startup, well, basically a bunch of people gathering together and deciding to build some project or a company. Then luckily they got some funding, or maybe they found some customer for that game or project. And they start cracking on that stuff. So on the early stages, they have a small team, which is like pretty familiar with all of the members, like each other knows each other. And they are full of excitement because basically they got this new cool stuff to work on. They've always dreamed about, and like, you know, they are still running on the fumes of happiness. They are definitely underestimating both their skills and their capabilities, as well as the amount of work that needs to be done. Because from the first point of view, it always feels like the feature that you've been assigned to, or maybe the project that you've been assigned to, is something that is not that complicated and it can be done in a couple of weeks or something like that. But then you start digging deeper, getting more requirements, understanding the field of the project, and then you start swearing because you realize that that your original estimation was kind of like pointing a finger into the sky. Again, they have the most like the worst thing that they could have, which is called code first. And this is related to the developers. So sometimes like young developers in young companies start working on the task or project by coding, instead of sitting together, discussing that, maybe building some plans or drawing some diagrams or whatever. And again, everything is here and now. So they try to do everything at the same time, and they are not progressing properly on the expected roadmap, or maybe they are not accomplishing milestones, but rather like hectically jumping from one feature to another, which is not good. But time passes, the company grows, and then it gets to the middle stage, which is called like adolescence, where I believe this is like the really vital period in the company or a startup, because basically during this period, that's why I basically put the picture of the house made of cards, because at this time you can either completely ruin your company or you can bring it to the new level. So this is the time when most of the problems have been surpassed, and you've hopefully sorted them out, and you got some experience from that situations, and now you act based on that experience. So you start making different decisions, or basically think that you will start doing them soon because you need that, because you need to define your path in the industry. You need to think how you could compete with the bigger companies, because basically you want to cover more of the market. And that's the time when the realization comes, because basically you start realizing the scope of the work needed, the responsibilities that you've got, and basically your current status of the company, where you sit in the world, on the market, between the competitors. You start doing more planning, and you approach tasks not by code first principle of practice, but rather by planning, discussing, and building some estimations and raising some risks whatsoever. And again, you start overseeing the bigger picture. You start also thinking about the future and possible problems that might arise based on your current decisions. And if the company is good enough, if the people feel each other, they will definitely go to the next stage. But if you allow a little bit of miscommunication or misunderstanding, or you won't be trying to develop the company will basically fall apart. And you'll go back home. Hopefully you'll have some fundings that you've managed to accumulate during the first stage and part of this stage. But unfortunately, usually the situation is a little bit different, where people have to starve. I mean, well, the money flow stops, and it's like a difficult part of life. But all of us are cool developers, so I believe we all move to the next stage, which is basically adulthood. So this is the time in company lifetime where the senior leadership team of the company starts thinking about defining some standards and documenting the processes, so that they know how to act in certain situations. And again, they have that knowledge because basically they've had loads of different problems and so on. And they realize that if you have everything documented, if you have the code documented as well, because basically this is really important thing, they realize that when you're bringing new people into the company, that massively helps. Then they try to unify the tech stack. And let's say at this stage, the company gets more customers, more projects to work on, because like usually this is like 3 to 5 years old companies. So basically, they kind of have multiple projects running in the teams. So they strive for that standardization. And here is the time when the company decides to build a framework. because they know that they have like, let's say 3 to 5 projects, and they're working on them in multiple teams, and they start understanding that basically they are not reusing something that one of the teams has created, or like they are having the same issues with QA while QA are doing the test process and so on. And yeah, this is the point where they decide to build a framework. Then at this point, the project might be quite messy. So due to some NDA reasons, I wasn't able to get some newer projects, but like I searched for some old projects in my stash that I could show you, like that are not under NDA anymore. And usually you have something like really messy where you don't have the pure structure in the code as well as in the project. So you have multiple prefabs here and there, multiple scripts here and there, no visible hierarchy or architecture. And usually you will find a couple of folders that are not used anymore. And they usually have something, if you can see the one on the second screen, like on the right from the vertical line, the selected folder is called old to remove. So multiple of this will appear on the project, and that means that the project needs like serious refactoring. And then you basically decide, what shall I put into the framework? Because I want to build that centralized system that will handle most of the common situations. But the answer to this one is, it depends. Why it depends? Because all of the projects are different. It's really difficult to find 2 similar projects. By that I mean like from different companies. So I can't give you the magic pill that will solve all of your problems. So that's why basically you need to do the proper research on your projects and see what you can move into framework. Usually it would be something that you can easily abstract away from the project, something that is not heavily relying on the code for the game itself or for the project itself. So here are a couple of examples on the left part of the slide. So basically, usually networking goes into framework because you would reuse that. I mean, if you're, again, it applies to your project if you're using some connection with the server, external databases, external services, whatever. But if you don't have that module, so you'll basically have everything except that. Again, asset management on the bigger or like more global picture could be extracted into framework. But again, there always will be some project-specific things that you can't really move away. Again, localization, analytics, purchasing, scene management, basically file system management. Everything can be extracted into that separate framework project. But yeah, basically the golden rule is don't rush at this stage, because this stage is really, really important. And if you make mistakes, you'll basically ruin all the approach, and the managers that you fought to get that time for refactoring and extracting everything into framework will start blaming you that you're breaking the system, it doesn't work, and they will maybe reconsider the whole idea of extracting everything into separate framework. But the first thing that you can do is get the project, get the stuff in the source code that you feel that can be moved, do the refactoring to extract it like into a separate subfolder of the project, remove all the hard dependencies and everything that is like really, really coupled, and try with that. After you've created this core core folder, which is on the screenshot, you can try removing it from the project and putting it somewhere aside. In the separate repo, it can be Unity project. If you're lucky enough and you don't need any Unity related things in that one, you can put it in pure C# project and use it later on as a framework. But yeah, again, this 4 steps that are repeating: plan it, design it, implement it, learn the lesson, and go to planning again. So the more you do this, the better, the shinier your framework will be, and the more reliable as well. So basically, what are the problems that are solved by the framework? And again, I put the picture of this electric screwdriver, because basically it's kind of standalone, because you can take it wherever you want. And you can put either drill bits and use it as a drill, or put the screwdriver bits and use it as a screwdriver. So technically it's like the multi-tool that allows you to modify it and then use and apply to whatever particular situation you need. So yeah, the benefits of having a framework is the centralized code base, which is somewhere away from the actual projects. Then you have the shared functionality, and hopefully you do, and you're following the DRY principle, which is don't repeat yourself. So you stop creating loads of code, which is actually the same, but written in a different manner based on the habits of the developer from the team who is doing that. It helps you to support and maintain the whole shared code base, because basically you don't need to go into each project and do the change when you found the bug, or maybe the company changed the approach to something, let's say payments. You need some change in payments. You don't need to go into each project and change that payments stuff, but rather go to this framework, change that once, test it once, which is another point, very important, because basically you save the QA resources. You don't have to test the same thing in each project, but rather go into framework project, test it there, verify that it works, and then you integrate it into the actual project. You do some little smoke test, and you're good to go to production. And again, project development, this is like related to the new projects in the company. Well, basically, as you have some code base, which is like the core one that you can build on top of it, the new project. You don't have to spend that huge amount of time building, again, that core functionality or project skeleton. So that helps very much. But there is no good without the bad. So our framework introduces a lot of problems. And one of them, the major ones, are build times, because basically you have to build this stuff, then you have to build the actual game. And again, this framework is growing bigger and bigger, because there are always some new requirements from the product owners or from the customers or from the other stakeholders. And you continue building this framework into something huge and monolithic. That's why we have this nice piece of rock in the middle of the screen. Again, it becomes a huge repository. And in a couple of years, most of the developers, not most, but basically some new developers who will join the team will start spitting around, because basically the system is kind of overcomplicated. It has too many dependencies. It has high coupling, and it basically affects performance in the end, because if you're adding loads and loads of things into that, basically you need to consume the whole project, and it brings maybe some things that you don't really need, which is, as far as I remember, the principle of Unity, who are adding loads of different things, but you can't properly select, or maybe now you can after they introduce the package manager. But anyway, these are the problems. So we come to the question, shall we give up the idea of creating the framework? Because basically we can see that there are loads of different problems that we bring with creating the framework. But the answer is, no, you don't have to. You can basically create the decentralized framework, which is like called by most of the people microservices. I don't really like that name because of the loads of hype around that word and loads of people trying to apply it all over the place, and usually it's not even like the good strategy to do in particular situations. But basically the good stuff that decentralized framework brings is we don't have the monolith anymore, so we can actually pick what we want and what we like. So the idea is that we basically break this one single framework into multiple small modules or packages, if you want, that are following the single responsibility principle in terms of a system. Also, you don't need that. I mean, the entry level into maintaining these modules is lower because basically the responsibility of the module is smaller. So you don't need to know the whole system and the whole application flow and how it works. So you can easily just dive into one of the modules. If you have a bug, fix the bug and dive into another module. Again, you have fewer problems with integration because the main problem when integrating the huge monolithic framework is that sometimes you don't need all of the changes that are already added to that huge monolith. You need just like some tiny fix that was done like particularly for your project, and you want only that one, but instead you're getting the whole loads of different changes in the project with the big monolith. And again, easier to maintain and support because basically you have multiple repos that are living on their own. You just go there, you fix whatever you need to fix, and you don't have to shovel the like thousands of files to fix the thing. So this is kind of an example how you could organize your existing system into this kind of like monolithic, decentralized framework. So you have something that is called the dependency, and to be able to use the whole loads of different small modules, you basically need some dependency resolution strategy. So for on this image, you can basically see how we managed to keep like small bits that are really game related in this like game package, and the other bits that can be either shared between the projects or they are really abstract and they don't need to be in the game. Because basically you don't really care, you care only about some service provider that has an interface, and with the help of that interface you will just get whatever like user experience, username and so on, or like some meta feature data. And you don't rely on that huge amount of logic anymore. So you can abstract away from it. You will have a separate team who will deal with that, and you just consume the stuff that you need to build the game and to make it look beautiful. And basically, as we just introduced the problem of dependencies, excuse me, there are some tools that will help you with this. It's been a while that Unity were asked to create something for dependency resolution, but again, there are a lot of different things that are more important in the moment. But finally, they came up with package manager, Unity package manager, and this is like the easiest way to do that because all of us are familiar with Unity, and we know the UI. We're like friends with that UI because we've been together for I don't know, more than someone could have been with their partners. So it's not that difficult. So the main idea of this is that you need to have some manifest, some basically text file that will describe the dependencies that you need in your project, as well as the source of that dependencies. And usually you would use some storage service like Artifactory or whatever, where you will keep your builds of the small plugins or modules, and then you will use some dependency resolution or dependency management tool to resolve the dependencies, which means to basically download them and put into the appropriate folders. And again, so I've put a couple of them here. It's like Unity's package manager, then you have Gradle, and you have NuGet. The problem with the NuGet is that currently Unity doesn't properly support that. So there are a couple of plugins on the internet that you can integrate into your Unity, and hopefully, fingers crossed, most of the time it will work. But that's why I also mentioned, if you're lucky enough and you can afford to put your code into pure C# code, C# projects, you can basically use some of the other tools as well. Gradle is a good one, but all the nitty-gritty of the configuration are something that usually pushes people away. But once you set it up, it's nice and easy to use, and you don't have to care about all the various problems anymore. Though you need to have a little bit of an exposure to the whole idea of Gradle and how it works, because basically that will help you a lot. And again, conclusions. Shall we build the framework? Yes, I would say definitely build it, because basically the benefits are much bigger over the problems. And if you can't build the decentralized framework from the beginning, you will still benefit from the monolithic framework, but in the time you'll be able to upgrade it to decentralized one, and that will save you a lot of time and a lot of patience and mental health. And again, shall you follow my approach or my guidelines? Definitely not, because basically this is not like something that you can blindly follow, and there is no single truth or no universal strategy or no magic pill. So you need to do the research. You need to check what can be extracted. Do you need to extract it? Because, for example, if you're building only, like, I don't know, small projects with one page or like one view, maybe it doesn't make much sense to create a separate framework that will handle like some logic, because basically you're just scripting and you're using one page. But in real world scenario, I can't think about that kind of project, even though I believe they exist. But again, it's a good step forward in the company development and your personal development as well. Which brings me to the end of this talk. Do you have any questions, or do we have any questions?
Awesome. Thanks for your talk, Yara. It was interesting.
Thank you.
So yeah, we have a couple of questions. So there is a question from anonymous attendee, which is, what is the best way to deal with unclear requirements?
Okay, so this is the thing that needs to be developed in the company, and it's called communication. So if the communication link is missing, then you end up having like problems with requirements, as well as multiple requests to redo or re-implement the feature or the project or whatever. So the best way is to have our beloved stand-ups or sync-up meetings. Some people say that this is waste of time, but basically this is the time when you can actually understand what the requirements are, and you can ask questions and you can get more information on what you're expected to do, so that you don't come back a couple of times after that and ask some other like questions about what did you mean at that this sentence, and did they implement it properly. So yeah, communication.
Awesome, thank you. Okay, so we've got a couple of questions here from Kieran. How does test it once mesh with projects being on different Unity versions?
That's a good question. Thank you. And this is also something that should come with the company development and company growth. And I'm talking about unification. So basically, whenever you decide on the tech stack for the company, you will ask and require all the teams to be on more or less the same version of Unity or other tools, so that you can be sure that the work that you're doing is not a waste of time. But basically, again, that's communication. Again, Unity is not that bad in terms of backwards compatibility, I must say. So even if some team is like not far behind from the other one, there shouldn't be major problems. But again, you can always resolve that with the help of versioning of the plugins or modules. So technically, you can cook separate backports for the teams who are using lower versions of Unity. But this is not recommended, because basically you're creating a lot of work for yourself as a framework team, I mean.
Awesome. Thank you, Ara. Any preferred approach for sharing these micro libraries? Git submodules, Perforce, workspace mapping, Unity packages, NPM packages, or manual integration?
Yeah, I think I covered that in the last slides, where I mentioned, yeah, that you can use Unity Package Manager, as well as, yes, as I believe Kieran mentioned, that you can use Git submodules, but sometimes using Git submodules can be painful.
Yeah, which one was your preferred approach?
So I've been working with Gradle for quite a while, so I believe in that, and I like it. I've tried Unity Package Manager as well, so I can't say that it's bad. It does the thing. NuGet as well, but I wouldn't use it in Unity projects. I would rather use it in some Xamarin projects or some pure C# projects. Yeah.
Cool. Awesome.
Thank you.
We have a question from an anonymous attendee. Should you write the framework in F#?
Thank you. It's a good question. Well, technically, you don't have any constraint in the language on the language, so you can use whatever language you prefer. Even though I believe like there could be some issues in functional languages, because the approach there is a little bit different, even though it's still the same. Because they're using they are reusing the functions. So technically, they have the same modules in functional programming languages that work the same way. But yeah, I mean, depends on what you like. You can build the framework even in C or pure C or C++, or like, I don't know, I believe even on Go.
Cool, thank you. Another question from Kieran. Any recommendations on quality control? Found that we tend to end up with a single person being the gateway to the library, and issues can sneak in if they're not available to review or gatekeep.
So yeah, the thing is, yeah, maybe I forgot to mention, so sorry, and thank you for the question. But basically, usually the framework is developed by not the only member of the company, like not only one developer, and there is always a group of developers, which is called a team. And again, if you keep one developer to work on something, you're always like, you can be affected by the bus factor. And whenever the person is is away or can't attend work or office or whatever, and you end up having problems. But yeah, basically, usually it's a team, and ideally you would need a QA team to support that team to get the best of what they can do and to get the best quality product in the end.
Awesome. Thank you, Aaron. We have a question from Tomo.
Mm-hmm.
How would you go about avoiding a situation when a framework consumer has an edge case requirement that isn't quite supported by the framework?
Thank you, Tomo. It's a good question. It's something that sometimes you need to deal with every day being a framework developer. Yeah, so the golden rule of programming is, or like, again, the open-closed principle is from Solid. I've been talking about that for quite a while today. But basically, you shouldn't, you should open it for extension. So whatever you're doing, you should encapsulate some core functionality, but you should also support extension of that functionality. So you shouldn't restrict like access or, well, basically restrict extension. The thing is that if the thing is really unique, you wouldn't add that into the framework because that breaks the whole idea of the framework. But if the team can't basically go or like work without this feature, then the framework developer or developers should give them some kind of exposure to the stuff that they need for that particular feature. But yeah, again, communication sorts everything out.
Awesome, thank you. It sounds like communication is your mantra for today.
Yeah.
Cool. All right, we have a final question from anonymous attendee. If anybody has any more questions, please get them in as soon as you can. When a company is in an adult stage, have some docs and standards, but do not enforce them and do not ensure test-driven development, mainly because they are client requirement driven, is there a way to encourage more of a testing and code review culture, or is this approach doomed when clients drive deadlines?
Thank you. It's a brilliant question, actually. And this is definitely the one which is hard to answer. So personally, I would recommend trying the TDD approach, trying code reviews and pull requests, trying all the best practices that programmers have developed during the years. Because, I mean, today you're a client-driven developer, but maybe tomorrow, you never know. Tomorrow you'll get some request where the client won't be that much involved into the process, and they will just oversee it from somewhere, I don't know, somewhere away, and they will be only interested in the final product. This is first. Secondly, I want to say that by introducing these best practices, you will also build the culture in the team where communication is easier and handled in the better way. Because whenever you start doing this, the team will speak the same language, and this will be your language. The customer won't understand this, but you'll be able to solve the problems faster and easily. It might not be that easy in the beginning, but once you get used to it, it will be as smooth and flawless, so that you won't even imagine living without those principles and practices. So I would definitely recommend it trying.
Awesome.
Thank you.
Great answer, Aaron. We have another question from an anonymous attendee. how can you encourage managers to adopt code reviews?
This is a good question. Thank you as well. So the thing is that you don't need to put it as a code review or something that is needed for developers. Because basically it's not the thing that only developers will benefit from. The thing is that if you have code reviews in future, you will basically eliminate the potential bugs and potential human error problems because they are easily spotted during the code review process. And you need to deliver the idea that you will reduce the bug fixing time. You will reduce the amount of bugs brought into production code. And you will also reduce the waste of QA resources on this. Because, for example, if you've introduced some changes that are, let's say, code breaking, or you're getting some null ref in runtime, and depending on your strategy for handling null refs, you might just get a crash, which is not good. And basically, whenever the QA starts testing the application and it crashes, he will basically tell you, oh, sorry, my dear developer, I can't actually work on this because the build is broken. Could you please get me another build, the one that is working? And again, you'll spend some time on creating the new build, fixing the issue, searching for the issue, because you wrote that code and you're pretty sure that you've written it the best way you could. But whenever someone from your team or even from the different team who is familiar with the language you're using is reviewing your code, they can easily spot some like simple mistakes that you haven't even thought about. And that will save time in the future and basically bring more money to the company. That's it, thank you.
Thanks, Yarrow. Again, another wonderful answer. Are there any more questions? Going once, going twice. Sold, okay. Thank you very much.
Thank you very much.
Kieran. Thank you very much, Yarrow. Are there any words that you guys want to give to the audience before we wrap this up?
No, it's just thank you for attending. It was a pleasure.
Yep, same here. Thanks for having me and thanks for attending. It was really good. It was really interesting to hear about someone else is fun with frameworks as well. Because, kid you not, most of what Yarrow was talking about, we've gone through in the last 4 years. Like, it's very, very familiar. That's why I had lots of questions. Thanks, Yarrow. Thanks.
Thank you.
Awesome. Thank you very much, everybody. And we wish you happy holidays.
Thank you. Bye-bye.
Happy holidays, folks.
Yeah. Merry Christmas. Happy holidays.